So today's topic is component object models, otherwise known as binary components or component objects or lots of different names. And this is really the cutting edge, maybe the wave of the future of software technology. So there's a lot of hype involved in this area right now, a lot of competition, a lot of competing technologies and views thinking their way is the best. A lot of people are trying interesting things, some of which are failing, some of which are succeeding. On the other hand, there are a couple of core ideas behind this, which I think are very good and are very powerful, and in one form or another eventually will succeed. So most of this lecture is not going to be Java-specific technology. It's going to talk about things at a fairly high Java language-independent area, which is very much the flavor and theme of component object models or binary components. So, with that inspiring introduction, let's go on. What are these binary components? Up to now, we've talked about things. We've talked about components when referring to GUI widgets. Okay, and binary components are something like the GUI objects in that they're things that you can embed in your program and use and give you useful functionality, but it's kind of an extension, a great extension of that. It's also an extension of the notion of classes. Okay, it's very much, you can think of components, binary components, as classes and object-oriented programming on steroids. It's just that idea, but then more so. The goal is to really push some of our ideas behind object-oriented programming, in particular reusable code, encapsulation, and abstraction to the next level. Okay? We have a lot of the stuff in Java with our class libraries and classes that you can use and build. Components, the component idea is to take that to the next level by abstracting it along a number of new directions. For example, to use a class in Java or any language, traditionally you need to have it written in the same language, compile it together. It has to be available at compile time, so you compile all these things together in one program and you use them. You can take classes and extend them to add additional functionality. So that means the classes can be pretty basic functionality, the library classes that you get. So some of the notions that components try and abstract against is language independence. It would be nice to be able to use a class that wasn't necessarily written in the language that your application was written in. Okay, maybe you want the functionality of the class to be written in some language that optimizes for efficiency, but you want to use it in some program that's optimized for programmer niceness, because all the really hard stuff is done in this class, and all you're doing is kind of organizing how it's supposed to be put together. Another thing is, I can call it location independence. We're trying to accomplish here. Independence. Right now, when our classes are basically running in the same process as our application, any utility classes, we'd like to be able to make things work so that the class could be running in a different process, or maybe even on a different machine, on a different machine on our company intranet or on the internet. So we would like to be able to make method calls or talk to classes that are halfway around the world and have it work pretty much the same way. We want to further extend encapsulation, so we only expose behavior through abstract interfaces. And as you can see, in order clearly to make this and this work, you really have to go do a good job on this, because if you don't know where the thing is and what language it's written in, you really have to do a good job in your abstract specification. Finally, we need to really work on these things tend to stress configurability. This is mainly driven by the fact that if something's written in a different language and maybe resides not on your machine, it's very hard to inherit from that. So in order to get the functionality, generality that you often get by taking a class in, say, the Java class library, and then inheriting from it to specify its functionality for your application, okay, you have to push that back in that the builders of the components have to kind of anticipate a wide range of different uses and applications and add a whole mess of configurable parameters that let you set things up to kind of customize this component for the way your application wants to use it. Okay, so the basic idea is classes, but abstracted so that you can pass things around instead of as source files, as binary files that can be used by different languages and can reside in different locations and whatever. And let's see, there are I would say three players in this game right now, and a pile of technologies. There's Microsoft's set of technologies, which go by the name of OLE, COM, DCOM, ActiveX. These are really the same underlying thing, but targeted towards slightly different applications. There's the Java versions of these, which are, yikes, Java Beans, RMI, Remote Method Invocation, and EJB, which we won't talk about too much. And then finally, there's a bunch of technology put out by OMG. It's a standards body. I think it's called the Object Management Group, or does anybody know what OMG stands for? No, I guess not. Anyway, they put out this thing called Corba, which is the Common Object Resource Broker Architecture. And they have a protocol. Okay. So kind of these are kind of protocols, and there's a lot of acronyms here. But these are kind of the three implementations of this technology I could think of. There's, yes?
Who's the intended beneficiary of what's driving this?
Well, it depends. This technology, when you think about how it's used, implemented, or the pieces you get, pretty much splits right away into two kind of user communities each, and some of these things are tailored to each user community. So I'll call the two applications scripted components, or scriptable. Let's call them scriptable components. And distributed objects. Okay? And the difference between those really depends on whether you're pushing the configurability and language independence and the ability to easily script functionality, or whether you're pushing the location independence and really the high-level interface description. These tend to be used by application programmers to glue together pieces to make applications. These tend to support very sophisticated enterprise applications.
So are the programmers driving it, or is the business driving it?
These are being driven to first extent probably by the people pushing the technology, and by, to a second extent, certainly the people in enterprise software groups who have, all these machines all over the world with all this data that they somehow want to get to work together. And this is driven by, the fact that it's very powerful from the software developer's point of view. It might be the future of application design. So let's talk about scriptable components first. This was, I'm not sure it was started by Microsoft, but certainly they have pushed it for a while with their Ole and ActiveX technologies. And the Java equivalent is Java Beans. And the idea is, going back to what I said, wouldn't it be nice if lots of functionality, instead of you as a programmer having to sit down and design all your functionality over again from scratch every time you wanted to do an application, or see if there were libraries in the particular language that you were using to help you. Say you had a bunch of components that encapsulated high-level functionality pieces that you wanted to use. For example, a lot of these revolve around building GUI applications. And some of the things that might be nice to have are, say, a chart component. Say you would, want to embed in your application the ability to graph data in various chart forms, okay, and just display the data that you have. Now, you could go through and spend, week after week writing a charting package, that displays in your particular program, but, that's kind of reinventing the wheel. Charting packages are not new technology, and they're out there certainly in standalone programs. There's lots of things that would do charts, or spreadsheets. There's lots of standalone spreadsheet activity. Wouldn't it be nice if you wanted to build an application that was not just a spreadsheet program, but wanted to embed spreadsheet functionality? Maybe one of your tabs in your tab display pulled up a spreadsheet to display your data. Wouldn't it be nice if you had a component that encapsulated chart display or spreadsheet functionality that you could just include and it would be there? The power of those of you who fooled around with the table widget here gives you the power of doing that. So the question is, how would you use this thing? And the idea of these things is they are scriptable at very high levels. To use a Excel spreadsheet, even from computer controls, is much easier than writing them. So the power that you need to kind of control one of these things is very simple compared to the computational power you need to write one. Another nice component for a different sort of applications might be speech synthesizer. Very, very complicated to write a speech synthesizer. But once you have one, the behavior is very easy. You send it a text string, and it either speaks the thing out the speaker or gives you a waveform back, which is the audio. So very simple behavior, but very complex implementation. So if somebody else did the implementation, gave you this black box that you could incorporate, and then you could just say, translate this, or play this, speak this sentence, and it would just happen for you. Now, the mechanics of what one of these objects look like depends, in detail, depends on which one of these technologies you use. In Java, it basically looks like a jar file or just a class file that you pull in, and but the thing about these things is they have to be configurable, since they're going to be used in a variety of programs, and you might want to use them slightly differently. They have lots of properties that correspond roughly to instance variables that let you configure what type of chart you want, for example, or what language you want the synthesizer to work in, or whether it's supposed to be high-pitched voice or low-pitched voice. Lots of configuration parameters because they're meant to be reused in a variety of contexts as is. And the cool thing about this component technology is that all these parameters and all these objects are self-describing. Okay? This technology makes heavy use of the notion of introspection. So you use the equivalent to the class in Java or interface descriptions up here to be able to tell, given an object that you know nothing about, the program can you can write a program that will look at the object and tell you what properties it has, not necessarily the semantics, but what the get and set methods are, what the types of those properties are. And once you know the types of a property, you know how to edit it, right? So if you have a property that's a string, you know how to give the user the ability to specify that property, because you can pop up a little string, a text input box, have them type in the string they want to configure, grab that string, use it to set the property, and you can write a program to do this without any knowledge of what that property is really doing. All you know is that you have getter and setter methods on a string property. Similarly, if it's a color property, you can pop up a color editor, and so on. So very powerful. So the kind of ultimate version of this currently is when you have components written in, say, COM and ActiveX, that you use Visual Basic to script together, okay? And this means that you can assemble your GUIs. You can basically do your entire GUI programming and maybe your entire application programming from a drag and drop visual editor. You just drag buttons on, you drag components on a layout editor. And since the layout editor can ask one of these components, you know, what are your set methods, what are your get methods, what are your properties, what events do you handle, all this, it can pull up this and give you a graphical environment to just set these things. And so in a very short time of playing with one of these graphical editors, you can do, you know, something that would take you probably days of programming. And it's probably much more compelling to see it. Right, and P/Java/JDK 1.3/bin:path. All right. CD. Now this is a demo I found on the Sun site, and the book talks about this a little. This is actually just a shadow of what you could do with, you know, a commercial product and you know, a real Visual Basic component editor and drag and drop layout thing. But it nonetheless gives you an idea of what we're trying to do here. So this is our template for the application that we're trying to design. And here is a palette of components that the thing knows about. All it knows is that it has these components. It doesn't know any of the details of these components. It just gets these components in the form of jar files. You notice it came up with a thing that said analyze jar files when it started up. And that means it's looking through all of these. It's figuring out what methods, through introspection, what properties they have, what methods they have, what events they handle. So here's one called Juggler, which I can just pick up. And it took me a while to figure out the buttons, but maybe I didn't figure out the buttons, or maybe we're crashed. Are we crashed? Oh, heavens.
Does the crosshairs change when you're picking up the button?
No, this is a really strange user interface, and it takes...
Looks like you may actually have an invisible component.
You think? I don't think so.
Maybe a panel or something.
No,
Why is there a dotted line around the outside?
Oh, that's the current selected component. But let's try one of these.
So maybe you should delete the component.
No, there's my juggler. I don't know why things were so weird, but there's my juggler component. So as soon as I drag and drop it, it starts going. And let's drag a blue button see
That's
if,
all it does, just a little animation.
okay. That's all it does. Okay. But this isn't what's cool about it. Okay, so let's drag another button. Okay, now I think I've got the hang of it. And let's move this puppy up here. All right, so now I've got, with doing very little work, I've got 3 things on my GUI, which is pretty cool. But now, let's say I want to do something with this button. Certainly I don't like the idea that it's just press. So let's change its number to, its label to stop. And I don't like its color so much, so we'll change it to pink. And now I want it to do something. So let's see, let's edit its events and say when I click it, that's the action event and the action performed routine. And look at this, it gives me this magic little pointer. And I say, okay, I want to hook it up to this thing. So I click, and now it gives me the list of methods that don't take any arguments that it found on this thing. So I could destroy it, but just let's make it stop juggling. So it does some thinking, blah, blah, blah. Okay, now, ooh. All right, so now let's do it again. Let's change our foreground, because this button we can't see. Let's make this puppy white. And so press is not very informative, so let's go to start. And we're done with that, and let's hook up an event to this one. Action performed. Hook it up to here again, and we'll have it start juggling. And it has to do some work. Now, start. Stop. Start. Stop. All right, one more. Here's this one's kind of cool. It's a little molecular display component. It has a number of different molecules you can display. This one is what? I forget. It'll probably tell me. Yes, here we go. I'm not even going to try and pronounce that, but it's by far the most interesting one. That one's pretty interesting too. But let's go back to this one. Right. All right, so, and let's do one more thing. Let's get another button. And we won't fool around with this label, but again, we'll edit its events. Its action event, mouse spaz. And we'll go here. And this one has a completely different set of things we can do. But rotate Y sounds like a fun one.
Can you send arguments into that too?
I think it's harder to do automatically. You would have to pop up a dialog box to bind what arguments you were sending in. But it's pretty cool. Now,
do multiple events on one mouse click?
Rotate X and rotate Y?
well, let's get a little risky here and take, I don't have a lot of mouse space here. Action performed, and let's bind it to this guy to the start juggling. Now, I rotate that once and start juggling. Rotate that guy once, start juggling. So if you think about how long it would take you to program up that application, or take me to program up that application, molecular drawing is not incredibly complicated, but very tedious. Notice the nice shadowing and shading and 3D stuff here. That's a bit of a pain to do well. And just the general, both building these things and then putting them together. Now, I believe, I'm not going to try this, I can actually dump this whole application out in some format and then just run it as an application. So this is what the idea of these things are for scriptable components. If you,
The source code?
no, it does. It would also produce the source code as well. So this is what you can do with these scriptable components. Commercial systems are orders of magnitude better than this because they're real and robust and have many more components and wizards and the ability to make new components. But they would let you build applications connecting these things together just really easily. My office mate is great at this back at my day job, and he pulled together a Visual Basic GUI app that did kind of some task he had to do in like an hour that used a fair number of components, and to do that by hand would have been a lot of work. So this technology really has the promise of letting the programmer really think about the high-level organization of your program and glue together these predefined components. Or if you like doing the low-level programming, you can go into the component manufacture business and make the world's best speech synthesis component, or the world's best juggler component, or the world's best chart component, or spreadsheet component. And then you can go and sell these or give them away, and people can embed them in their apps, and the whole world is a better and happier place. I mean, this is just very powerful stuff, and it's a little scary to traditional programmers that, oh no, I don't get to write everything all myself. But after a while, you get over it.
Where does the language independence come in here? This is
Well, right. The language independence, of course, you don't see so much in the Java independence because the classes are written in Java, and then they're scripted together in Java. But because, of course, Java is the best language for writing, implementing components, and it's the best scripting language, and it slices and dices and does everything. But if you're working in some other technologies, often, say, an ActiveX component would be written in C or C++, and then you would script it in Visual Basic, or you could use the same ideas to build complex components written in C, script them from Perl or from Tcl, or any number of scripting languages that let you organize a GUI and connect things up without worrying about low-level storage management and data layout and all that sort of thing. So that's where the language independence comes in. You're right. You don't see it so much in Java because Java is kind of a complete world. But once you get outside, you do see it. And it's easy enough to take Java things and wrap them in, put language bindings for another language in them. Actually, that's a little harder. But you can also take a C program, wrap it in a Java wrapper, and use that inside Java. So.
One of the list of things is a sorter bean that you can pick over there. Is that like a bean within a bean section?
Sorter bean. To be honest, I have no idea what this does.
Seems like a different class than everything else.
Algorithm bubble sort.
Oh, well, I've seen that one before.
Let's see.
It probably doesn't. It's probably a non-display thing.
Yeah, it could be. I have no idea. Let's see. Buying properties.
There's a demo app that just sorts itself, and you can watch it. So.
Oh. All right.
You guys back in
There it goes. Yay! It's starting.
So I guess we just need to.
Bubble
sort.
Wow, well that's going to take 1,000,000 years. All right, well that'll give you something to watch instead of me. All right, the last thing I want to talk about is a somewhat different targeting of the same idea, which is these encapsulated binary objects that you can use in various ways, and focus more on the language independence or location independence. I know, it's great. Up to now, we've been pretty much having our objects and our little app that calls the objects enclosed in one process, one program that's all nicely linked and compiled together. So this guy can know about this class, can do a new to get an instance of this class. It can then call a method on this class and use basically a normal procedure call mechanism and all that. So say we want to do all the things we do with our normal classes, but we wanted to do it on an object class that's hosted over here on a different machine connected by networks. So how can we possibly make this technology work and essentially keep this application looking pretty much the same? So this is, the beginnings of what the whole distributed objects deal is about. So to do this, we have to think about, all right, what do we need to do this? We need to be able to construct a new instance of an object. We need to be able to have a reference to an object. We need to know the interface of the object so we know what methods can call. Okay, so now we've managed to get something. We know what methods we call. We need a way to pass arguments. And get return values. And finally, we need a way to do the method call itself. So if we manage to implement all of these capabilities in this new scheme, so instead of talking to a local object, this guy talks to a remote object, we can make it work. And if we do it clever enough, we can make it work so that this application looks pretty much the same. So let's think about the interface one first. All right. To define an interface in, say, Java or any language, if you know your component's going to be written in the same language, you just use whatever the local technology is. For Java, it would be interfaces. For C++, pure virtual classes or whatever. And then you define what the methods are and what the argument types they pass are. Since we don't know what architecture this is over here, we don't know what language this is written in, we must define, and this interface is how this guy and this guy know about each other. We have to define things a little more generally. So there's a bunch of things called IDLs for naturally interface description language or interface definition language. And associated with each of these technologies, there's one of these things. There's like a Java IDL and a Corba IDL, and there's a Microsoft IDL, which is a variant of DCE IDL. And these let you describe things, write expressions that look very much like Java interfaces. Syntactically, they look almost identical, except that the data types that you use aren't going to be language-specific data types. They're just abstract, basic types defined by the IDLs. Fortunately, all languages pretty much implement the same set of basic data types, like integers, bytes, floats. Okay, all those. There's not very controversial. Arrays. Everybody pretty much knows how to handle those. Strings are a little controversial, so IDLs typically have an abstract string type, which is independent from C++ string type or Java string type. It's just an abstract string type that you use for communication and definition. And then it, of course, has to get bound locally to the proper equivalent on each side. So that's a good way. We have a mechanism now that both sides can figure out what the interface is and can communicate there. Now we need a way to construct and hold references. And the way this is usually done is by a mechanism called a proxy. Okay, this is a design pattern that one will run into. So we have a little piece of code here called a proxy, also called a stub, probably more commonly called a stub. And what this does is basically fake up this object over here. So this is, in Java, it would be a class definition. And it would be a class definition with exactly the same interface that we defined here, okay, that you could do new on, call new on, and call a constructor on and get a reference back. And you could hold reference objects on, okay. So it would look to this application just like if this object was implemented over here, it would look just the same. That's the image that this proxy stub is trying to create. So now this application can talk in the native language in Java using the regular new and regular method calls. It just talks to this proxy.
So, I'm sorry,
Yeah.
the proxy stub is something in the local process, or is it another process on this machine?
Think of it as something in this part's in the local process. Okay.
The object, wherever it exists, just got reference counted.
We haven't connected to this yet, but so we've just faked something up that looks like that object to here. We haven't quite connected it up. Okay. Now the next thing we have to do is somehow connect. We've now mirrored kind of the object on the application part. We now have to make something over here that can call into the object that looks like the application, right? And this is sometimes called the skeleton, I think, or it's probably another version of proxy, or the general proxy notion. The general proxy design pattern is to make something that stands in for something else and makes it looks like something else but isn't something else. So it's kind of a translator that kind of stands in between. I mean, you can think of this a little bit, the scheme of trying to make a telephone call between someone, say, in Germany who speaks German and English, to talking to someone in Japan who speaks English and Japanese. Okay, so you first have to set up a telephone call between them, and then you have to translate between them. And you know, if you get somebody if you have somebody who only speaks German, then somebody who speaks German and English, he can talk to somebody who speaks English and Japanese, who can then translate into somebody who speaks purely Japanese. Okay, that's one analogy for what's going on. And if that translation scheme sounds absurd, there's been ARPA projects to do exactly that. So, all right, so now we have something that the application can call normal in-process methods on the stub, and it's happy. We have the skeleton over here, which is calling into our remote object, so it's happy. It's doing a news and method calls on this. So now all we have to do is hook this guy and this guy together, and we are golden. So each one of these guys has a different mechanism to do it. In Corba, that is the job of our orb, which stands, I remember now, for Object Request Broker, which lives in a different process on the same machine, and will take requests from the proxy, which are now the proxy takes requests like constructors or method calls, translates them into this very general IDL language, and the orb will hook it up to the other side of this. Now, you can have if both of these processes were on the same machine, this orb would be able to hook them directly, but since they're over the network, this is the network, it has to talk to each other with our IIOP, which stands for Internet Inter-Orb Protocol. Just a way to go and talk to each other. In Java, this whole mechanism that does all this is RMI, for remote method invocation. And now you can do, since there's all these competing standards, they're also sort of interoperable. So you can there's implementations that do RMI over IIOP and maybe IIOP over RMI. So you could talk from Java to Corba, and everything kind of sort of works. Yeah.
Do enterprise Java beans work in with this Java to Corba thing at all?
Enterprise Java beans are one way of defining these objects, these remote objects over here. So it supports, it feeds in with this RMI and all of this. Enterprise Java beans go beyond that and are trying to encapsulate some additional functionality. Okay.
To deal with brokering requests across lots of different machines, lots of different.
Well, I think the main thing that that Enterprise Java beans, and this is getting a little ahead of ourselves, want to add is transactions. So they want to add this technology called component transaction monitors, which is kind of the big jump between Java beans and EJB. These guys, although this stands for Enterprise Java beans, these guys and these guys have very little in common, except they're ultimately Java classes at some level. But this is trying to give you support for distributed transactions. And the Java beans are more for in-process. But yes, the EJB technology is much more geared towards the distributed object than the Java beans technology.
I realize we're getting ahead of ourselves, but when you say transactions,
Right.
we're talking about like something happening over here in the process at where the stub is, something happening over here where the skeleton is, and the two making an agreement that they have actually. I don't understand.
Well, we'll talk. Transactions is really Monday's topic, but for now, transactions are a sequence of operations that have across them certain properties that are true. Okay, and we'll talk Monday about what the properties are. But they're just a sequence of operations that could happen in your network or on a single machine, and there's a set of 4 properties in particular that are critical for transactions. But that's a whole different topic. So what do we need to do to make this network thing work? It's actually not too tricky, though it's tedious. We have to be able to pass arguments, which means we have to do something called marshalling, which is taking all of the data structures in our language-dependent form, translating them into a network language-independent form, shipping them across the network, collecting them over here, and then retranslating them into the language-dependent forms over here. Similarly, we have to take the return value and do the reverse operation. You mentioned reference counting and stuff. One of the things that we have to do is remember, this guy is doing a new on here, or an allocate an object on here, which is translating it across to here, which is saying, okay, make me a new one of these, and then passing back a unique ID so that this guy can associate that unique ID with the reference pointer it gives back here. So the whole thing works consistently across the network. Okay? But now you have this network garbage collection problem, all right? Because you have people all over the network holding pointers over here, or people all over the network holding pointers to objects over here, and you have to know not only when your process has finished using them, but when all the processes everywhere have finished using them. And that gets to be a mess, but again, it's not impossible. It's just a matter of extending the stuff you would do in process with a lot of communication across the network. Okay. Plus, you have to worry about additional things in your remote procedure calls and the like. That what happens if you do a procedure call over here, you do a method somewhere in the middle of here, the network goes down, or this machine crashes, or all sorts of things can go wrong. You need an additional set of recovery tools over here to deal with that. Or if this guy's going fine, but then the caller deteriorates, how do you garbage collect all of his objects? A lot of details are hidden behind this kind of nice picture, which is why this is really the cutting edge of of enterprise technology. It's non-trivial to get one of these things up and running and reliable and maintainable. And so if the people who initially wrote the applications leave, you can still keep it going. So this is really the cutting edge of kind of what's known as distributed enterprise programming. It's fun though, and you can take this model if you're just not using sort of this technology, but just rolling your own. You can certainly roll your own scheme to do this sort of thing in a more limited sense. If you ever have an application where you have something over here you have to talk to and something over here. A lot of times what's over here is some interface to your database, your main database. So this kind of gives you an object wrapper around your company's database. So just something you should see, and someday you may end up having to deal with it, but certainly you won't in this course. But it's, no, I do not have an example. We don't have anything running for you at the moment. But nope, this is what gives software designers nightmares at night. Is the thought of getting one of these things up and running and stable and all this. If you think of the number of things that have to be up and working for your method call to happen, right? You have to have your process up, the proxy working, the orb working, the network working, this guy's orb working, and that process up. Okay? Yeah.
If you can get your hands on a copy of JBuilder Enterprise, there's working examples of this.
Ah.
Getting them to run is challenging.
Well, that is always the challenge. But yeah, J2EE, the Enterprise, we're using J2 Standard Edition. J2 Enterprise Edition, I think, has all of the RMI and EJB stuff in it and more. So, all right.